Radhe Radhe. Today's lead code problem of the day is 904 fruit into baskets. The questions specifies it will give you an array and it represents the type of fruit in each tree. What you have to do is there are certain rules which you need to follow, that you need to collect the fruits from these trees, and you have been given only two baskets, and each basket can hold a single type of fruit. And the second rule is, starting from any tree of your choice, you must pick exactly one fruit from every tree while moving to the right. So once you start picking up the fruit, you cannot skip any of the trees. You have to keep picking it up. Once you reach a tree with fruit that cannot fit in your basket, you must stop. And apparently, if you have reached the end of the array, then also you need to stop. So that's what the question suggests. Yep. Let us have a look at the constraint as well, which will help us to uh, finalize our approach. So this array can be of length 10 to power 5, and each element in this array won't be greater than 10 to power 5. Okay, so the basic approach here can be, you can start from any of the tree, and from there you can keep collecting the fruits uh, if you are able to accommodate those fruits in two baskets. Once this rule is violated, you can readjust your starting point. So like we can create a subarray starting from 0, 0th index, and continue till it follows the rule. Or we can generate all the subarrays and we can check whether it follows the rule or not. So how we can do that is, that will be a big O of n cube solution, because for generating all the subarrays, you'll have a for loop for starting indices, second for loop for ending indices, and then the third one will traverse from the start to the end, and it will see whether that is a valid subarray or not. I'll quickly show you the pseudocode for that. So this is how our approach one would look like. Like there's this for loop for starting indices, and this one defines the end of the current subarray, index of the current subarray. And then for validating, what we are doing is we will take one set, and starting from starting index to end index, we'll keep try to add element on this set. And if the size of that set is less than or equal to 2, it means it's a valid one. Then we update the max length. If it becomes more than that, we can break out of here, else we can break from this one. And this way, after iterating through each of the possible subarrays, we can return the max length. But you see here, this loops runs for big O of n, this runs for big O of n, and this also approximately runs for big O of n. So this becomes a big O of n cube solution, and n in our case is 10 to power 5. So this will definitely give you time limit, uh, time limit exceeded error exception. So we need to optimize this. So you see, the problem is about finding a subarray. So continuous subarray, I mean, once you start, you cannot skip any of the tree. So you have to take it in continuous manner. And once it violates the rule, you can shrink. If you think in sliding window, we need to shrink from left hand side so that the rule is again becomes valid. So I'll explain you with one of the example like how we will do that. Let me take an example. So for this example, let's say we have two basket. This is basket 1, this is basket 2, and let's say you started picking up from this position, which we'll call it as left, and it will be initially right as well. So we will insert 1 into our basket 1. So let's say basket 1 is being used for 1. Then we take up this. So this is different than 1. So we'll put 2 here. We'll again move our right here. So it is 2. So we can accommodate here in the basket 2. Then we encountered 1. We can accommodate that here. Then we encountered 2. So we can move here and accommodate this one as well. Then we move to this 3. We move to this 3 and we see we cannot put 3 in any of the basket. So what is the length till now? So we'll keep updating the length, or let's say max length. So 2 element in here and 3 element in here. So total is 5. We'll try to see like if we can get higher length. So we will start pushing our left to this side. So once we move that here, so one we can remove, and this comes here. This becomes our left. So this becomes our left now. Okay, but still we cannot accommodate 3 because the baskets are occupied. So we will remove this 2 as well, and we will shift our left 1 step forward. So left is here now, but still we do not have any baskets empty to accommodate 3. So we will move left 1 further. So let's say we remove this 2. The L is here. Now still we cannot accommodate 3. So we will further move our L forward and remove this one. Now if we see basket 1 is empty now, so we can use this. So L is at this position, R is at this position, and we can see if length is more or not. So it is not greater than 5 right now. It's okay. We'll start incrementing our R. We will insert 3 here. Okay. So next, let us move R here. It inserts second 3. Then we move R here. It gives third 3. We increment R, insert this 3. And then we move ahead and insert this 3. And then we try to proceed further, and this R crosses the boundary of this. And then we see what is the max length here. It is R is here, L is here. So it would be R minus L. let's say indices are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 1, 2, 3, 4, 5, 6, it should return 6. So it is R minus L. Once if it violates and then we are calculating the length, then it will be R minus L. But if at each step we are trying to maximize the length, it will be R minus L plus 1. So we will see in the code, like we'll calculate here, like at each step we are calculating. So we'll be using this formula. This is to check like if R has crossed the limit or not. So this time it is 6. So this is the max length. So to note here is you have to keep shrinking the window until one of the basket is empty. And how are we going to track this basket is using a map. Each entry will correspond to the basket. So at max, what can happen is, let's say you are filling up the basket. So basket 1 is having element, basket 2 is having element, and it when the rules gets violated, like you find third type of fruit, in that case one extra entry will be here, so which will help you know, like as we saw here, we had a set here which if the size is less than 2, then it means like it's a valid one. So similarly, we will have a hash map here which indicates what type of fruit it is having and how many frequency it is having. Let's say for in this example, 1 was present twice, so we need to keep shrinking the left until we have crossed this one, and in that order we had to remove 2 as well, fruits of type 2. This also we had to remove. So we need to keep shrinking once the rule is violated, and in order, like the other fruits can also be reduced. So that is the reason we need to keep the fruit type and the frequency of it. So this will help us when we are shrinking the our left part. Yeah, let us look at the code, and then we can finalize by looking at the code whether it's what is the complexity of it, and time complexity and space complexity. So yeah, this is the approach we will be following. So initially our left will be at 0, our right will be at 0, and we'll keep one variable called as max length, in which we'll return our answer. Let's keep a map as well. We'll call it as frequency map. Uh, okay. Now while r is not r is less than fruits dot length, it should not cross the array. So while r is, so what we'll try to do is, let's try to, as a first thing, we'll try to insert this in our map. So let's name it as frequency map, which will help us recognize that it's a map. Frequency map dot put fruits of R. And we need to have frequency as well. So frequency map dot get or default of fruits of R or 0, and then incremented by 1. So inserted this, and the standard sliding window protocol is, after doing this we need to try to shrink the window if it it invalidates. our rule. So try to see if we need to shrink the window, and if yes, then shrink it. So we'll see what we need to do here. Once we have shrunk it, we will increase the R. Before increasing the R, we will see if our max length can be updated. So here what I was saying, like we are trying to update the max length at each step, not like after completely moving the R and then finally doing it. So in that case, that's the reason like we'll be having calculating it as R minus L plus 1. Dot max of, if this is more than keep it, otherwise if this gives you a higher value, update the max length. And finally we return the max length. So now the task is to write this shrinking part of the code. So how to do it is like if the size of your map is 3, so the possible size of your map will always be 1, 2, and 3. It cannot have any value larger than 3. So initially it will be 1, like when you have observed only one type of fruit, and when you encounter second type of fruit, it will have the second entry. And when you encounter third one, it violates the rule, so we'll keep removing elements from the left until the size of the map becomes 2 again. So condition would be like while frequency map dot size is greater than 2, then what you do, you remove frequency map dot, you'll reduce the frequency first. It will be, you need to from the left, okay. Fruits of left, L, or yeah, basically L. Here we need to get directly L, not default. We do not want to go to negative, so directly get this and subtract -1 from it. And we will just see like if frequency of this has become 0, then we will remove this entry from the map, and that will again bring us in the condition where the map is invalid state, or only we are using 2 baskets. Then let me remove dot remove the, and this restores condition. Looks good. We missed L, so we'll keep increasing L. Yep, looks good to me. Let's try to run this. Okay, this is a function. Integer cannot be created with Boolean. Okay. That messed it up a little bit. No worries. It runs the sample cases. Let's try and hit submit. Okay. So if you see for time complexity, we are always moving forward this r by 1, and it goes till length of the array. So r is moving till big O of n, and this while loop, it tries to shrink from left hand side, and it can never cross r. Whenever violation happens, at that time this while loop will run and it will try to shrink. So at max this can go is till big O of n, and it doesn't go like every time, right? So you see L doesn't start from 0 all the time, right? Like let's say if it has already moved 5 indices when it has violated, next time it will try to sync from 5 onwards. Like let's say whenever violation happened, it doesn't starts from 0 all the time. So in the complete array, don't look at each step. Let's say holistically, in complete array, L can move at max from 0 to n minus 1. So, yeah. So that makes time complexity as big O of, let's say, 2n, which turns out to be big O of n. And space complexity, as we discussed, like in the map, it can be maximum 3 entries. So that makes it as big O of 3, which is mostly constant. So big O of 1, we can say. And that's it for today. Thank you.